Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at Design Master Electrical for AutoCAD. We're going to be looking just at some questions that have come in over our support channels, answering those to take a look at some of the different ways you can use our software. If you are attending the training live, you can ask questions in the chat box. If you are watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497, and our email address is support@designmaster.biz. The first question that we're going to take a look at that we had come in was a customer was asking if our software can do cost estimates. And the short answer to that is no. You can't directly do a cost estimate in our software. However, we do have features for doing takeoffs. So the software is set up so that you can do a takeoff, which is kind of like the first half of a cost estimate. We can give you the quantity counts, and then you can take those quantities to another program, Excel, one of the various estimating packages, and do a more complete cost estimate on it. Because the cost estimates require a little bit more input and data than we wanted to put into our software. So the cost estimate is a separate program, but we can at least give you the takeoffs, the quantities that you can then input. To do that, you use the takeoffs commands. So these are all located here. We can do a takeoff of this area. I've got some receptacles and whatnot on this drawing. I'll insert a takeoff area. You give it a name, which will just label the report. And then you got a couple other options. We'll come back and look at those. You draw a box or a shape surrounding the area that you want the takeoff for, and that's what's going to do our takeoff based upon that area, so that you know it's counting the things that it actually finds inside that box, so that you know that what's being counted is what you're expecting. Then we can run the print takeoff area command, select that area, and it'll count everything for us and output it to an HTML file. And then from here, you would take these numbers to your cost estimating program. So it lists all the equipment, gives some information about them, and then their quantity counts, the receptacles, and then also various circuit lengths. We have the length of circuit, which includes the branch circuit and the home runs, just the branch circuits, just the home runs. The number of loops, which kind of is going to correspond to the number of different segments, so you can know how many terminations you're going to need. I wouldn't cut wire based upon these lengths, but I certainly, you could get a rough estimate of how much wire you're going to need, something a little more accurate than just doing a square foot calculation, for example. And these lengths do kind of depend on you having your loops in here, so we can calculate them. If you don't have the loops, we'll kind of do an average length, and that's not going to be as accurate. So if you want more accurate takeoffs, you do want to have your loops inserted. On the area, we have the couple options that we ignored. One is whether you want to include those circuit lengths or not, so you can turn them off if you don't want those included in your calculation and output. You can also choose whether you're including different systems, new, existing, or whatever else you have defined. Then we also have the ability to do a takeoff of the distribution equipment. So basically all the stuff on your one line, your panels and transformers. Those don't necessarily always show up on drawings, and so this will give you a takeoff for all of that stuff, basically for your one line. And then you can do equipment that's in the database, but not on a drawing. If you've done a kitchen schedule and you haven't placed all those things in the kitchen, but you still want to do a takeoff, you can use this command. Looking at the distribution equipment, that will be the more interesting of the two with this project. You can see it lists each panel. It gives you the number of breakers and of each type on that panel, and a little bit more information about it. And then if you scroll down, we also transformers, enclosed breakers, so each different type of distribution equipment we list. Then we give you totals in the project for each type of breaker, broken down under a couple different headings, the voltage, AIC rating, and then the actual size. And finally, the feeder lengths, and then whether these are calculated based upon the location of the devices on the drawing, or whether they have been input by the user. And you saw there's the error calculating the feeder length, and you'll see here that there's a couple places where it says the feeder length could not be calculated. So if you have stuff that is not inserted on the drawing, it's going to alert you that, hey, there's a feeder. It doesn't know how long it is because it hasn't been set. The next question is, how do I configure the default settings for my equipment schedules in new projects? So when you have an equipment schedule, you can place that on the drawing. Run this command here. I can insert that schedule, and we have the ability to edit the title, column labels, and column order, so you can adjust what that schedule is going to look like. You can adjust your widths and the different columns that you're going to show. So you can have a general and a kitchen equipment and a mechanical equipment schedule that all look a little bit different. Put that on the drawing here, so you end up with a schedule that looks like this. So in a project, that's easy. When you insert the schedule, you make all those settings, and then that's what it is for the project. In future projects, you might want to have those settings set ahead of time. You've got this all set up, and you want to use it again on another project. To do that, you need to use equipment standards groups. So under equipment, at the bottom, we have equipment standards groups. So in the standards, we have a single group right now, just the general. But you could set the default settings using the edit settings there, which brings up the same kind of insert schedule dialog. You can choose what your defaults are, including this button to specify your default columns and column labels. So you can make your settings here, and then future projects are going to pull this in when you use it. You can actually have multiple different types of schedules. So we can have a general, and then say we have a mechanical. And on the mechanical, for example, we might want to show some of the MCA and the MOCP values. If I can find them, those are down here. So we'll turn on MCA and MOCP. So we want to show those on the mechanical schedule, whereas we weren't showing those on the general equipment. So now we have two schedules defined, and then we can pull those into the new project. When you start a project, you have this option here for which schedules groups you want to pull in. So it'll pull in the ones you select. There's not going to be any equipment in them, but all the settings are getting pulled in, basically. So you can choose if you want to pull in all of them or some of them. And this is where you make that choice when you start the project. Next question, again related to reusing information. Customer had created some projects in a receptacle, and the question is, how do I use them in other projects? The answer is that you copy it from your project schedule to a master schedule. So if we go to receptacles, we have the receptacle project schedule, and then we also have the receptacle master schedule. This also applies for light fixtures and low voltage devices, switches that are all working on the same basic concepts. So we run the receptacle project schedule, and here's where we define the receptacles we can insert in this project. You can see we've got a couple defined here. We could create a new one. And now you want to be able to reuse this on another project. Now there are two ways you can do that. If you're in the other project, you can run the import from another database, where you can run this command, go to the other project, and import the record. You can also go to your master schedule, and you can import from the project schedule that you're currently working in. Or actually, you can import from any. It's going to ask us which one we want to import from, so I have to go track that down. So we'll import that quad that we just created. You can import the quad, you can import everything. And you can either create a new record or update your existing record if you're looking at one. So we'll create a new record. Click OK. It pulls all that information in. And now on other projects, first, when you start the project, it's going to, if you select the general receptacles, it'll pull all those receptacles into your project. So you can pull them in that way when you start the project. And also, you can, in the project schedule, you can import from the master schedule here. So we can import that quad. So if we didn't have this quad anymore, I delete it from here. No quad in the project. We can import from the master schedule, and it pulls it in for us. Next question, how do I display a 3-circuit home run? So if you have a combined home run, how can you show that with the software? And we have the way we can do that is when you draw the home run, you combine it with other circuits. So I'm going to go over here. I've got a number of different circuits. Say we want to combine all the circuits in this kitchen together. We run the circuiting command. We do the draw home run in loops. The first device you select is where the home run will come from. And then you have another option to select additional options. Normally, you would just press enter, and it'll do just the home run from that one device. Instead, if we select that device to do the home run, and then select an object on this circuit, so we're going to do circuit A12, come down here, we'll get A16 as well. It will connect all those together, and it will combine the home run combine the tick marks for us, and on each device, it will show the circuit number for that device, so you can tell which is circuited to where. There's a couple other options that you can use to control how this ends up looking. If we go to options, we can control whether we have a combined neutral or not. This actually is not code compliant at this point because you need to have a common trip, or you could, if you notated that you have a tie between the breakers, this would work. Otherwise, you actually would need separate neutrals here. So we can come in here, and in the home run section, there's the share neutrals on combined home runs option. That is currently set to yes. You really want that probably set to no. I should update my project so that is defaulting to no. You also have the option if you want to do multiple arrowheads for combined home runs. That's currently set to no. We get a single arrowhead. If we change that to yes, we'll actually get an arrowhead for each circuit on the home run. So I'll change those two settings. And I'm actually going to change one more. I want to draw the tick marks on the home run, on all the loops as well. I'm also going to set display tick marks on loops to yes, so that we get the tick marks on all of those loops. Now, if we draw the home run, it'll update everything for us. Again, we select the two devices to combine it. And you'll see we have the additional arrowhead. So if that's how you like to draw your combined home runs, if that's the drafting standard you like, we can do that. You'll see that it's got the separate neutrals, and then the tick marks are actually correct. We're getting the right number of wires at each point here. If you do want to combine the home runs, combine the neutrals on the home run, the way we recommend you do that with the software is you go into circuiting and select that circuit from the drawing. Make sure I get it. Okay, so we're looking at 12, 14, 16. You can take these single pole breakers and change it into a 3-pole breaker. Change it from a 1-pole to a 3-pole breaker. And it will keep all of those devices on the separate phases of the circuit that they were on before. So they're still on the separate phases, but they're on a 3-pole breaker, and so now they have a combined trip, and so you can actually have a combined neutral at this point. And so now if we draw the home run, we no longer even need to say that we're doing the combined home run because it's implied, because it's one circuit at this point. You'll get your combined home run, again, the tick marks, and again, all of the circuit labels for each individual device. Next question from a customer is on the panel schedules. He wanted to know how to display the loads in VA instead of KVA. The way you do that is we've got an option for it. You go into options and you change that, change the option there. It's under panel schedule load display units. We can display it in KVA, VA, or amps. We'll change it to VA for this example. And we can update the panel schedule. And you'll see that all of our loads are now in VA rather than KVA. However, you will notice also that the labels on the schedule have not changed. That's because those are hard-coded in some blocks. And so to change those, you actually need to change the block definition. So we need to go in here and change this header. You can do that under customization. I am going to open a block from this drawing. I'm going to select my header block. And we go in here where it says load KVA. And we'll change that to say load VA. Same thing over here. And I save this. We'll call it 3-phase header dash VA. Save and close that drawing. Since I created a new block, we need to assign that to a new schedule type. So we do that by changing our distribution equipment schedules. So this is currently using the phase with breakdown. It's using this 3 header, phase 3 header. We can copy this whole thing. We'll do the copy, and we'll call this the panel phase breakdown VA. And then we'll change that header to that new block that we created. And then for MDP, we can change the block that that schedule is being used for that. Change it to that panel with phase breakdown VA that we created. Update the schedule. It'll pull in the new schedule for us with the new block. So now it says load VA. And you'll also notice that that schedule happens to be different than a couple other pieces in here. Apparently I've got some mismatched blocks in this project. So we would need to go update those other blocks as well. But we're going to not spend time messing with all that drafting. It's just a matter of getting the drafting right, adjusting the locations of all those lines. The next question is related to outdoor lighting. The question is for glare. How can you calculate the lighting level at a certain distance above the ground at the edge of the property line? So typically for glare standards, it says, no more than a certain number of foot candles, 5 feet above the ground, and just on the edge of the property. So our standard calculation is going to give you the calculation at ground level over an area. You can change that. So we could take this area and say instead of calculating at 0, we could calculate at 5 feet. But you don't want generally 5 feet over the whole area. You're really only concerned about 5 feet at the edge of the property. So what we would recommend is that you insert a calculation line. So we have the command to insert, we have the basic command to insert a calculation area, and we have a couple extra commands. We can do the sloped area if you have a stairway or something, and then we also have these 2 line commands. So we can insert a calculation line, and it'll calculate the photometrics on that line specifically. So we can say, okay, we're going to calculate on that line, do every 10 feet. And we want to know at 5 feet in the air what the lighting levels are. And then you draw your line, you trace out the boundary or whatever you want. We'll do just this one edge. So now we have this additional line here where we're going to do our calculations. And then we can run the calculation command again. We'll calculate everything, and it goes along that line and gives us the calculation, the foot candle levels at 5 feet along that line. So that would be the best way to calculate those values for your glare calculations. Another customer was asking about the voltage drop. They were looking at their voltage drop schedule, and they were noting that the voltage drop listed is higher than what they were calculating when they were using their hand calculator. And the question was, what should they look at to figure out why those two things were different? Generally speaking, if you have a situation where the voltage drop doesn't match what you are calculating by hand, it's a difference of inputs or what is actually being measured. So it's a matter of just making sure that what you are calculating is actually the same thing that our software is calculating. So looking at this voltage drop schedule, we have here the feeder voltage drop, which is typically what's being looked at. And this is a cumulative voltage drop. So the voltage drop here at panel DP includes the voltage drop through T1 and from MDP. So it's including everything. If you're looking at just the voltage drop from T1 to DP, you can do the math and subtract it out. You can also insert that as a column on the voltage drop schedule. So when we run the voltage drop calculation, we can do the specific feeder voltage drop. Put that up here. And we run the calculation, and it'll include that column for us. It's going to run into here, so I'll move it down. It's doing some calculations for the branch circuit, and so it actually needs to take a look at those other drawings as well, which is what that warning is. So it'll open up those other drawings. You'll notice that it put that big X on there, and it said that the calculations are not right. When it says that, you can press F2, and it will list where it is having trouble. So this will tell you how to fix that X that's showing up there. There's a couple pieces of equipment on here that do not have lengths, and so it can't calculate the voltage drop. For our purposes, we'll ignore those, but if you wanted to, you'd have to go in there and either insert them on the drawing, like it says, or manually input the length on the device. But looking at the T1 to DP, you can see that the voltage drop on this feeder, this is the voltage drop from that specific feeder that's being included, which is different from the cumulative. So you want to make sure if you're looking at just a specific feeder, comparing it the voltage drop on the feeder versus the whole thing. The voltage drop through T1 is really big. That's because there's also the question of what we do with transformers during our voltage drop calculations. We have a knowledge base article talking about voltage drop and transformers that I'll pull up. You can find this by going to support and knowledge base and searching for voltage drop and transformer options would be the easiest way to find that. And there's a setting for how we handle voltage drop through a transformer. And so there's 3 options. We can include the voltage drop through the transformer, which is demonstrated here. basically there is a voltage drop through the transformer, and so that's just included, which is how you typically end up with higher voltage drops through your transformer. So if your transformer has a really high voltage drop, you're probably including that. So just be aware that's where that voltage drop is coming from. You can also choose to ignore the voltage drop through the transformer. So the transformer will have 0 voltage drop, but you'll continue to accumulate the voltage drop from the feeders through it. And then you'll also have the option to reset the voltage drop. So the voltage drop will actually go back to 0 on the secondary side of the transformer and start at 0 and go from there for the secondary side of the transformer. These two are approximating adjusting the taps on the transformer and just how aggressively you're adjusting them. To the ignore, is not adjusting them as much as the reset is, because you can raise that output voltage to basically account for the voltage drop. In the software, that is under options. Under the distribution equipment, voltage drop and transformers, you have your 3 options: include, reset, and ignore. So I'll change that to ignore the voltage drop. And right now we've got the 0.5% voltage drop through T1. Run that, insert the schedule again, which will run the calculation again. And you'll see that the voltage drop on T1 dropped from 0.5 to 0.02. So most of the voltage drop at that point was coming from the transformer itself and not the actual loads. Next question from a customer is, how do I change the scale of a drawing after I've already inserted devices? So all of our devices and everything is scaled based upon the dim scale setting in AutoCAD. It's currently set on this drawing to 48 or 4 feet. So this is a quarter scale drawing. If you wanted to make it an 1/8 scale drawing, you would change that to 96. But just changing that doesn't update everything. If you put in something new, it'll come in correctly. So if I put in a new receptacle, you'll see that it actually comes in at a different size because this is now an 1/8 scale drawing. But everything else is at the old scale factor. To get that to update after you've changed your dim scale, I would recommend insert a device, just make sure it's right, and then run the coordinate drawings and database command. Run it on just the one drawing, and one of the things that command does is checks your scale factor and adjusts everything to match. Next question was, how do I show recurring panel templates in the one-line diagram or on various schedules? So we have recurring panel templates. These are for like apartments or something where you've got lots of the same thing and you want to have a single panel that you're using multiple places in your project. So you'll have 10 of these. You'll have the template and then you'll have 10 instances, but you only want to show one example of that, say on your voltage drop schedule or in your one-line diagram. And the way you actually want to do that is choose one of the instances and use that as the typical. So we'll go ahead and create a recurring panel template. So we've got our template, and you would connect your devices up to it however you need to. And then we can create instances of that in the project. We'll call this instance 1. So that would be our first instance, and then we could put another one in. Typically these are going to go in separate apartments or something like that in the project. We're just going to put some so that we have them in the project. And then you connect these the same way you connect any other panel using the connect distribution equipment command. So we have these 3 panels now in the project, but they're all very similar and we don't necessarily want to show all of them on the fault schedule or the voltage drop schedule. By default, none of them are going to show up. And what we recommend is that you take one of them and say, okay, I want to show this one on, say, my voltage drop schedule. So we can go back to the voltage drop that we were looking at. Say I want to show it. And then we can also change the description. And we can call this an I typical. So this is saying that, okay, this is just what a typical I panel is going to look like. And then if we update the voltage drop schedule, it'll include just that one panel here underneath L. So you'll see that now we have that I panel labeled I typical, so it doesn't have the I1. So that's how you would show it on the voltage drop. And you can do similar things for the feeder schedule or fault schedule or showing it in your one-line diagram. The last question I'm going to look at is a question of ground sizing. In this specific example, The customer had a transfer switch, and they had it being fed from the normal power and then from emergency power. And you have the two wire sizes here, and they both have number 2 wire, but you see they've got different grounds. We've got a number 4 ground here on the left and a number 8 ground on the right. And the question from the customer is, why was he getting different sized grounds in this case? And the answer is that ground sizing is there's some subtlety and nuance to it, and he ran into some settings that were triggering different ground sizes based upon the settings that had been chosen. Before we look at the transfer switch, basically there's 2 ways you can size a ground. You can size it based upon NEC 250-122, which is the equipment grounding, and that sizes it based upon the size of the upstream overcurrent protection. And then you can also size it based upon 250-102, which sizes it based upon the conductor sizes of the feeder. You use the equipment grounding when you're connecting basically to a panel or anything, most anything, and then you use the second one, the supply side bonding jumper, when you're connecting to a separately derived system, which is typically the utility or a transformer. So in our software, when you connect to the utility, we use this setting. And when you connect to a transformer in your project, we use this setting. The sizes of those wires are controlled by your wire sizing option. So if you go to customization and pull up wire sizing, that's why we have the service ground and equipment ground. This is the 250-102 and this is 250-122. So you'll see that you have different sized ground wires for each wire ampacity based upon which of those 2 tables you're looking at. And so when you're in the different situations, this is how the software chooses which wire size is going to be used. It was a 70 amp transfer switch that he had upsized the conductors to 90 amp conductors. So if we go take a look at the 90 amp wire size, you'll see that they both should actually be number 8 ground. So he's expecting a number 8 ground, and you're getting a number 8 here, but over here it's actually been upsized to a number 4. So the question again then becomes, why are those different? So it's been upsized. You can see on the right it's connected to a transformer. On the left, it's connected to this breaker and then to this panel. So on the right, it's using the 102, the service ground sizing, and on the left, it's using the equipment grounding. Again, those are both number 8, so you expect it to be the same. But he has upsized the conductor wires. So this is a 70 amp transfer switch, but he is saying I'm upsizing my conductors to 90 amps. For service grounds, that doesn't matter on the ground size, so you just get the number 8 like you expect. For equipment grounds, when you upsize your conductor, you have to upsize the ground with a proportional area as you upsize the conductor. So he went from a number 7, a 70 amp conductor, which is a number 4, to a 90 amp, which is a number 2. So since the wire size got bigger, the ground size also has to get bigger. So that's why you went from a number 8 to a number 4, is how that ends up working out for that calculation for those 2 sizes. And the reason that he was using 90 amps here, and because he didn't have an upstream overcurrent protection, because in this case, he had modeled the breaker separately as a separate piece. So he's got a 90 amp breaker here, and then connecting to the panel. So that's really providing the protection for 90 amps. So it wasn't being set necessarily at the transfer switch. And so that's why the software was seeing it as something being upsized. So your options for getting that right, there's a couple different ways. If you set the upstream breaker to be a 90 amp breaker, that's the simplest way, and then it'll just give you the number 8 wire. So that would do it. You can also just always manually resize the ground if you want to. So you can just give it a number, but mostly getting this upstream overcurrent protection matching your conductor amps will get you the wire size that you're probably expecting. And if they're different, then we are going to upsize the ground for you. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.